Alrighty, thank you. Hi, everyone. I'm Emily Waring. I work for a nonprofit in California called Sustainable Conservation, and we're 30 people. And our mission is to advance the collaborative stewardship of California's land, air, and water. And I emphasize collaborative stewardship because we often bring together groups with different ideas and come together for environmental solutions that make economic sense. And then on the right there, I have a photo of one of our examples of that. That's my boss and our farmer partner standing with a manure subsurface drip irrigation that we co-developed with an irrigation dealer, Netafim. And um, in my work, I focus on mitigating nitrate leaching in the San Joaquin Valley, so all the Central Valley in California. And here I have a graph of shallow and deep wells and their nitrate concentration. And about 1/4 to 1/3 of that nitrogen is attributed to excess dairy manure. So Um, one of our major goals is to find beneficial uses for surplus dairy manure, and surplus dairy manure is estimated to be 75 to 100,000 tons. So we wanted to do a manure shed analysis. Um, in environmental and economic align our goals as an organization and how we do our work. So we took the county scale and then we took more granular data and we could do with using granular to or synthetic explanation. Um, um, it contributes provides 1/5 of this is a ground dependent area. So we're ignoring for now. And then California has the ambitious with trying to protect our water quality, water quantity, and greenhouse gases. So that gets work with. Triple cropping for annual crops, and then a lot of orchards and vineyards. So that results in a lot of human consumed crops and also or human consumed crops that are both high value and then have a bit of a food safety concern. So this combination has led to a lot of state collected, driven by a lot of state initiatives, and I'm going to highlight a few here. So what we used in this analysis was land use data collected by Land IQ, most understanding water consumption, but it's highly accurate land use classifications compared to cropland data layer. The water board is interested in from a water quality perspective what they're doing, so they're required to report nitrogen generated, how much they apply, how much is removed from the crops, and then what is the data. And they provide latitude and longitude and herd numbers, and they're interested in that for tracking methane digesters. So as we manure, so I wanted to highlight the assumption we made to get this into a quantification of plant availability. So we started with manure generated, and that was from the herd numbers, based, and then standards for the type. how much nitrogen, and 30% of that is manure nitrogen available for application. And organic and that would be really variable over a season, over space and time, of course, but we just picked something. Nitrogen, and I put fertilizer as percent of that the environment, so volatilization, denaturation. So we're considering those losses in our 170 nitrogen from Key Valley and obviously of clouds, and then a range of recoverable plant available nitrogen after that. So mostly from this graph, just wanted to show that we have a lot of, but that they're fairly well distributed throughout these counties. And then in terms of nitrogen demand, we took classification data, combined that with fertilizer recommendations and USDA yield data, and came up with the requirement by polygon. And then to show here, so we are using a lot of, or we are crops that use a lot of nitrogen, but we also are also generating a lot of nitrogen in the same area, but we're still importing about 500,000 tons of nitrogen annually in the form of synthetic fertilizer. And one more caveat for our methods, to account for the fact that fertilizer or manure is slightly less efficient, applied all the fertilizer requirements by 1.16. I touched diversity in the San Joaquin Valley and California in general, but here's a graph of we have and I guess so in a lot of areas in we grow all of these different crops within 10 miles. Um, and I also just wanted to highlight there's a lot of different crops. So for all of those, so two things that diversity that these growers may be more interested in so we have this nitrogen, well, from dairies, and then we have all this up range, a lot of different companies. So here I have a 5 mile square, and the blue dairy, about 40 dairies have different so this and as much manure as you can within the constraints that we set. So we ran 3 simulations. One, manure can travel 2 miles from dairy and 10 miles away from a dairy. In the first where we said manure can only 64,000 tons of manure, and quality, this is us assuming that they are applying every single in 2 miles. This is just a simulation. But then as we go out farther, we get you can apply, then we only have 15 tons. Let's quantify how could be. So we broke these up. This is the graph that I have. So it varies a lot per county, but we broke it up by forage crops and non-forage crops, and we received more, and then we totaled up all of fertilizer needs, and we estimate that fertilizer could replace 80,000 tons of fertilizer within 10 miles of a dairy. So, original question, can environmental data spark a circular economy? We say yes. So kind of our encouragement for a circular economy, we think, was the conclusions that we came to were improved a lot compared to just looking at a county analysis of N surplus. And then we did all this with just latitude, longitude, herd sizes, and accurate land use data. And we think, yes, our conclusions would be of where manure is currently applied, because we had to make a blanket assumption that it was only being applied to forage. So for our next step, so are looking forward to email if you have strong opinions. So that's step number 1, and then step number 2 is dig into the water board data, which is a little bit tricky, and then communicate the constraints that we find, because they've learned a lot of lessons with that data that they're collecting. And then number 3, account for manure details, so like fraction and composting, etc. And then so we in our apply to forage I engage with specific commodity groups to understand, or specific commodity in a given county, or and that have a high nitrogen requirement. Questions?